Hey guys, so today we're starting factoring trinomials. What we've spent a little bit of time doing is multiplying binomials and trinomials and monomials and getting some sort of polynomial at the end. What this is working backward. It would essentially be like we've spent a lot of time working on 3 times 2 is 6, and then it would be spending time realizing that you can make 6 backwards and make it 2 times 3. So that's what we're doing. But when we do this, there's a specific type of number that needs to meet 2 requirements to make this work. So what we have here is I call these diamond problems, and they're kind of like little puzzles that are going to help us when we go to actually factor. So we're not actually going to get into the factoring part today besides these kind of diamond problems. So the way it works is you have a product at the top of this X. If you were to enclose it, it'd make a diamond. That's why I call it that. And then the bottom is the sum. What you need to do is find 2 numbers that will multiply, aka product, top number, add the bottom number. So if we look here, you can see here that the 20 is the product and 12 is the sum. So I like to make a little table. And here's the product, 20, and here's the sum, 12. And what I'm going to do is find numbers that multiply to 20 and then add them together and see if they're 12. So for example, 1 times 20 is 20. When I add them, I get 21. That's not 12. 2 times 10, that is 20. When I add them, I get 12. That's good. I can stop there. So I always like to start with the lowest numbers and go higher and higher. That's just how I do it. But there you go. So these 2 numbers make this true. So those become the factors, 2 and 10. You can put them in either order. It doesn't matter. So for example, let's come down and look at these numbers. So you need to make sure to read because it says in this part, find the factors. The first number, the factors of the first number. So the first number is the product. The second number is the sum. Sorry. I misread it when I was reading it out in my head. So that means when we do this, we take the product and put it up top and take the sum and put it on bottom. Okay. So we need to find 2 numbers that multiply to 72, but add to 17. All right. Let me make my little table here. So again, firstly, 1 times 72. Well, when I add those, I get 73. Not so great. Then I can do 2 times 36. When I add those, I get 38. Still not 17. I believe that this is divisible by 3. I'm going to use my calculator to check real quick. 72 divided by 3 is 24. So 3 times 24, those add to 27. I'm getting closer, notice. I started at 73, then 38, then 27. What about 4? 4 times 18. Ooh, closer, closer, closer. You add those, you get 22. So notice I've done 1, 2, 3, 4. I can't do 5 because 72 divided by 5 is not a whole number, but it is divisible by 6. Let me check. It is. 6 times 12. If you add those, you get, oh no, so close. 18. You guys, I have to start another little thing over here. 72, 17. So I had 6 times 12 is 72, but when you add those, you get 18. Oh man. So does 8 go into 72? It does. It's 8 times 9. Well, what is 8 plus 9? 17. We did it. Boom. So the numbers are 8 and 9 because when you multiply them, you get 72, and when you add them, you get 17. Whew, that was a rough one. Sometimes you get them quick, sometimes you don't. That's okay. So, next one. The first one's going to be the product. 24 goes on top, 10 goes on bottom. So that means we want 2 numbers. When we multiply, we get 24, but when we add them, we get 10. So 1 times 24. Well, that adds to 25. No. 2 times 12. You add those, you get 14. No. What about 3? 3 times 8. Those add to 11. And 4 times 6. Ding, ding, ding. We got it. It's 10. So that means that these numbers are 4 and 6. So see, kind of like a puzzle. Last one. Sorry. Again, the first number is the product. The second number is the sum. It goes down below. We want two numbers that will multiply to 15, but one number that will add to 16. So again, 1 times 15. You add those, oh, we got 16. That time we did it on the first try. So I know you probably thought it was funny before that I always started with 1 times the number, but here we go. It worked out really well this time. So that means that these two factors are 1 and 16. Okay, they're, oops, I'm sorry, 1 and 15. Azor, come on, get your head in the game. Because they're factors of 15, and they add to the specific number. Okay. Oh. Of course, wouldn't be math if I didn't want to complicate it. So we have to see what happens when I add negatives into the mix. So if you noticed above, all of them were already positive, which was really, really nice. But what happens when we add a negative in there? So it says how factors are affected by whether the sign of the product, by the sign of the product and the sum. Oh my gosh, Azor. The product and the sum. So if they're both positive, like above, that's great for us. That means the factors are both positive. Okay, so these are the factors. If the top is positive, but the bottom is negative, well, that means that this and this are negative, because a negative times a negative will give us that positive up top, and a negative plus a negative will give us that negative down below. So if the top is positive, negative, and they add to a negative, then they're both negative. Then we have this last scenario here. If the top is negative, regardless of whether or not it adds to a positive or negative, the signs are going to be opposite. So you can either have positive, negative, or negative, positive, doesn't matter. Okay? So the reason I kind of split them like this is because there's another thing you can look at, is if the top are positive, then notice the factors are the same, both positives, both negatives. If there's a negative, then the factors are opposite. So if the product is positive, if positive product, then factors will match. So you know that they'll be positive, positive, or negative, negative. It just depends on the sum. Here, if the product is negative, so if negative product, factors are opposite. One will be positive and one will be negative. All right, so here we go. Down here, let's do some practice. Put it into practice. So this one, the product is negative 50. The sum is negative 5. Oh my gosh. Negative 5. There we go. So this matches this last box over here, negative on top, which means these two signs will be opposite. So I want two numbers that will multiply to negative 50 but add to negative 5. Okay, well, let's ignore the negative just for 1 second. We know 1 times 50 is 50. Okay, one of these needs to be negative. Well, if they add to a negative, then the bigger number should be negative, right? Because if we make the one negative, they'll add to positive 49. If I make the bigger number negative, they'll add to negative 49. It's still not negative 5, but at least we got a negative. So that's not it. We also know 2 times 25 makes positive 50. Again, we make the bigger one negative because they're supposed to add to a negative. that adds to negative 23. That's closer to 5, negative 5, but not quite. I can't divide by 3. I can divide by 4. Nope, I can divide by 5. 5 times 10. Make the bigger number negative because we want them to add to a negative. Well, 5 plus negative 10 is negative 50. There we go. Or negative 5, sorry, we did it. So the 5 is positive, the 10 is negative. You can always double check it on your calculator. Make sure that when you multiply these two numbers, you get negative 50, and when you add them, you get negative 5. Okay, next one. The product is 36, and the sum is negative 20. Well, if we look up here, that's like this one. The product is positive, the sum is negative. That means that both of the factors are going to be negative. So we have positive 36 and negative 20. Okay, let's do this. We have 1 times 36. And again, both have to be negative because that's what the rule is. A negative times a negative will be a positive, but a negative plus a negative will be a negative. That's negative 37. That's not right. Next one, 2 times 18. So that gives you positive 36, but we need them both to be negative. That still multiplies to positive 36, but it will add to negative 20. We did it. So the factors are negative 2 and negative 18. If you check them on your calculator, multiply them, they'll get positive 36. Add them, you'll get negative 20. All right, last one. Here we have a product of negative 100 and a sum of 21. So again, this fits into this last category. Since the top is negative, the factors will be opposite. One will be positive and one will be negative. So I have negative 100 and 21. Okay, so remember, 1 will be negative. So I have 1 times 100. Now, if I want them to add to a positive, the smaller has to be negative. Because now, when I add them, it will be positive 99. You don't want to get a negative number, so you make the smaller one negative, which is not 21, so that doesn't help. 2 times 50. Again, I want it to add to a positive, so you make the smaller one negative, and you get positive 48. Nope, that's not right. 3 doesn't go into it. 4 goes into it. 4 times 25, make the smaller negative. Oh, 21. We did it. So that means we have negative 4 and positive 25. Okay, so again, use your calculator. If you need to, if you forget which one of these should be positive, try both. Make the 1 negative the first time, then make the 100 negative the second time to see if you're getting closer to your answer. Use your calculator to help you out. Okay, so this is all fun and stuff, but how does it apply to polynomials? Well, we have a standard, a standard way to write quadratic trinomials. So if you remember from classifying, quadratic means the highest power is a 2, and trinomials means there's 3 terms, 1, 2, 3. That's what we're working with specifically. How does this play into a diamond problem? Well, each number, notice only the numbers are in colors and the X's are not, is assigned a letter, A, B, C. The product, the number that goes on top, is take the A number times the C number, and it goes up here. The B goes on bottom, and that will be your sum. And now you have the top and bottom number. You just do the same thing we did before. So, for example, in this case, if we do A times C, 3 times 1, that is 3. Now I have my top number. Then I get B is 4, that's my bottom number. I need to find what 2 numbers will multiply the 3 and add to 4. So I need to put a table somewhere, it doesn't matter where I put it. Multiply to 3, add to 4. So positive, positive, that means these two will be positive. So 1 times 3, wouldn't you know it, adds to 4. So that means my factors are 1 and 3. So all this is it changes the way we find the top number and the bottom number, but then you find these the exact same way. Okay, so here we go. Let's look at a few. So I like to write ABC under the numbers, A, B, C. Okay, has to be written in standard form. That's important. And here is my X. AC goes on top, so 2 times 5. B goes on bottom. That's the number 7. Make sure to include positive and negatives. Now, I have this. I need to find, well, what numbers multiply to 10 but add to 7? Again, since they're both positive, both of the factors will be positive. 1 times 10, that's 11. Nope. 2 times 5, that's 10. Great. So my factors are 2 and 5. Let's do the next one. We have AC. I'm going to make that A, B, C. Yep. A is 3. C is 5. 3 times 5 is 15. There's my top number. B goes on bottom. B is negative 16. Okay. So now, remember, if the top number is positive, but the bottom number is negative, then both of these are negative. And if it makes you feel better, you could even write those in right now. You know that's going to be a negative and a negative. I need to figure out what things will multiply to a positive 15, but add to a negative 16. Well, 1 times 15 is 15, but I need them both to be negative. Those still multiply to positive 15, but they add to negative 16. So I already did it. First one, great. This is negative 1. This is negative 15. Those are my factors. Let's do the next one. Oh no, I have A, B, C, but I only see the number C. What numbers are here? Well, remember, if you don't see a number, then it's the number 1. So this is a positive 1, and that is a negative 1. Very, very important. You do not drop the negatives. So A times C. A is 1, C is negative 20. So negative 20. B goes on bottom. That's a negative 1. I need to find what two numbers will multiply to negative 20, but add to negative 1. So remember, if this is negative, then the signs will be opposite. So I have 1 times 20. If I want them to add to a negative, the bigger one has to be negative. So if you add those, you'll get negative 19. It's a negative, it's not the right negative. What about 2? 2 times 10. And make the bigger one negative. If I add those, I got negative 8. Ooh, closer, but not quite. Then we have 4 and 5. Again, make the bigger negative. So the negative is the 5. If I add those, I got negative 1. So I get 4, negative 5. They multiply to a negative 20 and add to a negative 1. Okay. Next, we have A, B, C. A times C, that's 3 times negative 8, that's negative 24. B goes on bottom, that's a positive 2. So now, again, if the top number is negative, then the two factors, one will be positive, one will be negative. Again, you can write them if you want to, doesn't matter. And they add to a positive 2. So, for example, 1 times 24. One of these has to be negative. Since I want it to add to a positive, then the smaller one is negative. So, a positive number, not the right number. All right, next one. 2 times 12. Make the smaller one negative because you want it to add to a positive, and I get 10. A positive number, not the right positive number. What about 3 times 8? Make the smaller one negative. That's 5. I'm getting closer. And then 4 times 6. The smaller one is negative. That gets me 2. Awesome. So here I have a negative, so that's my 4. This is negative 4, and then positive 6. Again, you don't have to write those negative and positive in, but if they help you, go for it. And you could have flipped them. Doesn't matter. Next one. A, B, C. A times C. 4 times -1 is -4. Then B goes on bottom, and that also is a -4. Ooh, interesting. We need to find numbers that multiply to a -4 and also add to a -4. Okay, so remember, if they multiply to a negative, only one is negative. So again, if you want to put that in, that we have opposite. This time I'll put the plus sign over here and the negative here. Doesn't matter. So we have 1 times 4. Okay, if I want them to add to a negative, I need to make the bigger negative. If I add those, I get -3. Well, that's not right. What about 2 times 2? Okay, well, they're both the same. So if I make this one negative, they add to 0. Well, wait a second. Okay, well, I picked the factors. There's no more factors of 4 or -4. I know that they multiply to a negative, so only one of them can be negative. If they both are negative, they'll multiply to a positive. If they're both positive, they'll add to a positive. Oh no. That's interesting. Well, you know how there's prime numbers and prime numbers are only divisible by 1 in themselves? Well, sometimes you get these and they can't be factored either. When you can't factor them, they're not called prime, they're called not factorable. I know, super fancy. So sometimes if you come across it, first check your work because let's be honest, I'm the queen of mistakes. But if you're pretty sure you've done it right and you can't find it, then the answer is not factorable. Now remember, don't just start putting not factorable on everything, but sometimes it happens. Just like sometimes you have no solution or infinitely many solutions, you can have something that's not factorable, meaning these numbers don't exist. Oh, there's no possibilities, at least not whole numbers. All right, last one. So again, we'll put a 1 here for A, B, and C. When we do A times C, 1 times 12 is 12, and then B goes on bottom, that's -7. So we need something that multiplies to 12 but adds to -7. Well, when it's positive, we know the signs will be the same, either positive, positive, or negative, negative. But since they add to a negative, we need both of them to be negative. So 1 times 12, we make them both negative. That's -13. That's not good. Well, it's not bad, but it's not the right answer. What about 2 times 6? Both of those have to be negative because they multiply to a positive. When you add them, you get -8. Ooh, so close, but not quite. Let's try 3 times 4. Again, both have to be negative so that they'll add to a negative. Dun, 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 -7. So that means this one is factorable. 3 and -3 and -4. Okay, so in addition to using the positive and negative diagrams, maybe you want to write down somewhere that in addition to that if a positive and negative add to a positive, the bigger number is positive, right? If you have two numbers, one's positive, one's negative, and you add them to a positive, then that bigger number has to be positive. Whereas the reverse is that if a positive and negative add to a negative, remember, I'm not talking about a negative or positive, opposite signs. If they add to a negative, the bigger number is negative. So I was saying that over and over again here. If here, one of these is positive and one's negative, but they add to a positive, so like this one, then I make the bigger number positive. So notice I always picked that bigger number to be positive. 24 was positive, 12 was positive, 8 was positive, and that's so when I add them, I get a positive result. Okay? Again, you have a calculator on your phone. Just use that to double check, but don't cheat. All right. Awesome. If you have questions, of course, let us know, and good luck.